Okay, so today we will be discussing scatter plots, line of best fit, and two-way tables. Here is the first page of vocabulary. You can actually pause it here if you want to go over these. It's just gonna make the video go longer if I read them out. Same here with your vocabulary continued. If you wanna, read through, you can do that. Okay, so on to our standards. For our scatterplot standards, it's to construct and interpret scatterplots for biurative measurement data to investigate patterns and associations between two quantities. Describe patterns such as clusters, outliers, positive or negative association, linear association, or nonlinear association. For your line of best fit standards, for the first one, it's construct and interpret scatter plots for biurative measurement data to investigate patterns of association between two quantities. Describe patterns such as clustering, outliners, positive or negative association, linear association, and nonlinear association. For the second one, it's known that straight lines are widely used to model relationships between two quantity variables. For scatter plots that suggest linear association informally fit a straight line and informally assesses the model fit by judging the closeness of the data points on the line to the line. For the third one is the use of the equation of a linear model to solve problems in the context of biurative measurement data, interpreting the slope and intercept. For example, in a linear model for a biology experiment, interpret a slope of 1.5 cm/hr, which is centimeters over hours, as meaning that an additional hours of sunlight each day is associated with an additional 1.5 centimeter in mature plant height. For your two-way table standards, it's understand the patterns of association can also be seen in biurative categories data by displaying frequencies and relative frequencies in a two-way table. Construct and interpret a two-way table summarizing data on two categorical variables collected from the same subjects. Use the relative frequencies calculated for rows or columns to describe possible associations between two variables. For example, collect data from students in your class or whether or not they have a curfew on school nights and whether or not they have assigned chores at home. Is there evidence that those who have a curfew also tend to have chores? Okay, so on to our scatter plot. For this situation, for scatter plots, you let the horizon axis or the x-axis represent the number of seasons, while you let the vertical axis or the y-axis represent the number of viewers. Then you would graph the order pairs for seasons of viewers. Now, over in the right-hand corner, you have your television ratings. For seasons 1 through 6, you have your different amounts of views. You would then put it onto a bar graph or scatter plot graph, whatever you want to call it, and it'd come out looking like this. It would look at like this because you would put your seasons in order with your views, no matter which way the plots go. You see here that the plots go down, and which is odd because most graphs go up. Well, here is the explanation for that. Associations. With associations, it's a type of scatter plot. It is, for that one, it was a negative association where the plots went down. But it could also be a positive association where they go up, or no association at all, where they're just in random spots. You also have your linear associations and your nonlinear associations, in which the data points lie close to a line, while nonlinear is the data points lie in the shape of a curve. Okay, so on to the next thing. You have your line of best fit. Now, in this situation, you would graph each point on, like a scatter plot, but then you would draw a line that fits the data. About half the points are above the line in this situation, half below line. You would judge the closest points to the line. Most of the points are close to the line. That's in this situation only. It could be very different for others. But you would see here, you have all your points, you put them on, and then you would start the line from your first data point going up. Or, yeah, going up or down. Okay, so for two-way tables in the what it is you create a table using the two categories. For this situation, it is cell phones and MP3 players. Now it gives you some points up here. It gives you some of your data. You would then place it in a table like this, and you can see that some of them are not filled out. Well, what you would do is because it gives you certain data points, or you would take the 78 total and subtract the 57, which will give you your MP3 players. Then you would actually add for 13 plus 9 to get your total here, all of which would equal out over here. Now, this is actually what it looks like completed. You have it where that's actually 21, 22, 70, 30, and 100. So it just comes out in that situation. It could be very different for any others. It still look the same, but it would have different numbers, of course. So, for two-way tables, you also have relative frequency. A two-way table can show relative frequency for rows or for columns rather than actual values. By analyzing the relative frequencies in a two-way table, you can determine the possible associations between the two variables. For the one we just showed on the last slide, it actually has it here as well. You would basically put it. You would put it into a fraction, 57 over the total of MP3 players, actually people who actually have MP3 players, and then you would get 0.73. You would do the same for the other ones, except for the number. Then, you would do it with the number that is already there, and then the other totals. You would eventually come out and it'd be the total for this situation: 78 semicolon 1.00 and 22 semicolon 1.00. Now, based on the relative frequency value of 0.73 in this situation in one of the cells, you can imply that most students that own a cell phone also own an MP3 player. The data suggests that over half of the students that do not own a cell phone will own an MP3 player. Well, that's it for this video. Thanks for watching, and I hope it did help you out. Be sure, please go look at other videos on this channel for more mathematical information, and that is all.